Welcome to the second season of Adapt, Climate Change and the Built Environment, where we interview professionals across the private and public sectors to discuss adapting the built environment to a changing climate. We believe that ensuring climate adaptation to extreme weather and evolving climate patterns needs us to re-examine what it takes to make our buildings, infrastructure, and communities resilient and adaptable, so that our society can continue to thrive for years and decades to come. And with that, let's get started.
Hi, and welcome to another episode of Adapt, Climate Change and the Built Environment. I'm Jessica Mederson. As always, I'm here with my fabulous co-host, Mónika Serrano. Hey, Mónika, how are you?
Hi, Jessica. I'm doing well. It's wonderful to speak with you.
I know I get very excited over every guest, and I am very excited because we have so many wonderful people, but I have to admit, I am especially excited about the guest we have today for our episode because he is Jim Schneider. He is the executive director of PCI Mountain States, and he is an expert in my favorite thing, concrete.
I know, it's very exciting.
It really is. He also has Wisconsin connections, which of course will come up in the podcast. So yes, I'm excited about the Wisconsin connections. I'm excited to talk about concrete because obviously concrete plays a big role when we're talking about resiliency to climate change. We actually met Jim as we were starting to present at various conferences. Jim was also presenting because again, in the climate adaptation space, concrete plays a big role.
Absolutely. And we can't talk about concrete without talking about how heavy it is when it comes to embodied carbon. In fact, if concrete were a country, it would be considered the third largest emitter. The good news is that there are a lot of alternatives now for Portland cement, and I think we get into that in the conversation. So it will be a very wholesome conversation that touches both on climate adaptation and climate mitigation.
Just spoiler alert, if you guys listen, you'll get to hear a polka reference. And what's a podcast without a polka reference, right, Mónika?
Absolutely. So let's get started and learn about concrete and Jim Schneider.
Hey, Jim, how are you?
I'm great. How are you guys doing?
Good. Thanks so much for joining us today. This is going to be a fun conversation.
Hey, I am a fan of the program and I'm happy to be here. Thanks for having me on.
Let's start learning a little bit about you, Jim. Can you tell us what PCI and what your role there is?
Yes. So PCI is the Precast Prestressed Concrete Institute. So that is a technical institute and sort of a trade association, a certifying body that represents precast prestressed concrete manufacturers around the country. My role is the executive director of the Mountain States region of PCI. So we have kind of regional chapters. I'm out in Denver and I work with producers in Colorado, Utah, Wyoming, Montana, Idaho, a little bit in the Pacific Northwest also. So basically, precast prestressed concrete is plant-produced concrete that is has pre-stressing strand poured into the beds over the strand and allowed to cure, and it kind of gives it additional strength for less weight. Very strong, durable, off-site construction method. So that's essentially what our industry is.
And so tell us, I already mentioned that you're from Wisconsin. So how did you make it from your Wisconsin roots to Denver and concrete?
Oh my gosh, I've bounced around over the years to find my way here. Yeah, so I grew up in Wisconsin. My family's all still back there. My uncle is a bona fide polka celebrity in Wisconsin.
No
and
way.
He is. Yeah, he's in the Wisconsin Polka Hall of Fame.
Oh, that's awesome.
He's got a band, German style polka band. And my first job in Wisconsin was as a polka disc jockey. So I grew up on a dairy farm and I was a polka disc jockey. It doesn't get much more Wisconsin than that. But
that
I moved from there.
Wisconsin.
Right. But I moved from there to Southern California for grad school, where I used to live across the street from Dennis Rodman. So talk about culture change. And then I was in Chicago for a while. That's where I got to work with PCI. So PCI is headquartered in Chicago. I lived there for quite a few years and then moved out here to Colorado in 2015. I've been here since, so love it out here.
Jim, we would like to get a little bit deeper into precast concrete. Can you tell us any kind of innovations that you were seeing as a result?
Yeah, I mean, I tend to look at precast as, of course, I'm biased. It's the industry I work in, but it's a highly engineered material and innovative in and of itself. It's been around for a while. It was a lot more prominent in Europe before it really took off here. PCI as an organization has been around for about 70 years now. But it really allows you to get very precise where it comes to things like mix design, because this is it produced in a plant. And you really can get sophisticated in how it's produced. And then the assembly of it is also extremely fast because it's this offsite construction method. It has these sort of modular benefits of material efficiency in producing it in the plants. And then also it gets transported to the job site. It's labor efficient. It doesn't require a lot of labor on the site. It goes up very quickly. So one of the big advantages of precast in terms of basic innovation is just its speed, especially when where schedule became king, particularly a few years ago. That was a real important aspect for a lot. We see projects come to precast simply because of the schedule. We do a lot of schools and things like that have tight schedules, and so there are advantages there. But also when we're talking about things like durability and sustainability, resilience, I think this idea that we have these very smart engineers working on in these controlled conditions in the plant allows us a lot more innovation in terms of what we can do and working to make the material stronger, more durable, also more carbon efficient as well.
That makes sense. It's more like you can manipulate it a little bit more, so it has more potential to be perhaps more sustainable or more resilient, etc.
Yes, and you could do more with less in many cases.
Are there certain types of buildings that use more precast concrete than others?
Yes, there are certain things that precast does a lot of. I mean, for one thing, parking structures is a very big thing for precast. So something like, I know probably over like 60% or so of parking structures in the US are made from precast. And I always say it's kind of like if you go into a parking structure and it's nice and open and you have room to maneuver and you don't have these columns all over the place, that's precast. It's because it has these, you can do these long spans and have, an engineer once described a parking structure to me as just basically just stacked bridges in a way, because it's carrying that kind of load, and precast is very good for that. And frankly, for also transportation, we do a lot of work with departments of transportation around the country doing a lot of bridges. That's probably about half of the business of our industry is in that space. But other building types, schools is one that I think really is well suited to precast because of its longevity, durability. Something we can talk a little bit more when we talk about sustainability is energy efficiency potential. We have insulated precast panels where it's like a sandwich panel with an exterior precast panel that may have some kind of architectural finish on it or thin brick, so it mimics masonry. And then you have a continuous layer of insulation built right into it, and then an interior width of concrete that it's extremely energy efficient. It utilizes thermal mass as a benefit, which basically is the concept where, concrete acts like a thermal battery and it slowly absorbs, slowly releases heat. So you can actually, even under ASHRAE code, increase the potential R value of your wall system over what its material R value is, simply by utilizing the physics of concrete in your calculation. So there's lots of advantages, I think, for, when you think about a school, something that is a long-term investment in a community. Precast concrete brings that durability, that energy efficiency, safety, all those things to that type of material. But we also see, like here in Denver, quite a few offices that use precast, healthcare. We've seen some multifamily go that way. One kind of, I think, cool building type that is really good for a lot of different reasons in terms of really maximizing a building footprint is you can have like parking on several levels and then a building above it, like a podium type construction. So that's something we see a lot more of too.
I love concrete. I think you bring up great points. The durability of it, the length of it. Just look to the Roman Empire to see how long concrete can last, right? They were the original concrete experts.
Right.
But you did bring up kind of the elephant in the room, which is always kind of the Achilles heel, now mixing my Greek and Roman history.
Well, they mixed themselves up quite a bit, really, when you look at it. So the Romans borrowed a lot from the Greeks.
That's true. Okay. Thank you.
Yes.
But yeah, the Achilles heel of concrete has always been the sustainability part. There's a lot of focus now in the built environment, in the construction industry, on embodied carbon, which is basically the carbon that is generated during the building process itself, as opposed to like the operational carbon, which comes after you've got the building complete, the carbon that's emitted as you heat and cool it, for example. And I don't know exactly what the stats are, but concrete is a huge part. The creation of the concrete really is the creation of the cement that is a huge part of the embodied carbon footprint for most buildings. So let's talk a little bit about that. Like, are there ways, you kind of mentioned that precast can help with that, right? By making basically lighter, less concrete because you use the strands as well. That can help reduce the carbon impact. Are there other things you're seeing in the concrete industry that address the sustainability aspect?
Oh yeah, and I think it's, first of all, to kind of address the question, absolutely. The statistic is, I think, something like 8 to 10% of global CO2 emissions come from the production of concrete. Now,
Wow.
that's for a couple of reasons, right? And I should also note, like, steel is right up there too. It's about
Yeah.
the same. So yeah, buildings in general are a major impact, both in terms of energy and materials. And so with concrete, first of all, you have to remember it is also the most commonly used material on Earth, with the exception of water. So obviously there's a lot of it, and so we need it, but we also need to make it more efficient. So I think there's a couple of different ways to think about carbon and concrete. And one of the things that our industry has been talking about for years, and while it's true, yes, the initial impact of concrete is where it's all at. Like, once it's produced and it's installed, that operational carbon piece is great, like, because it really doesn't continue impact. And in fact, there's even, you can have the conversation about the carbonation sink concept, where basically concrete reabsorbs CO2 back into itself as it ages. So that's all well and good. But the fact is yes, we still have to deal with upfront carbon costs. And so there is a lot of effort going on within the industry to both, it's important, I think, to eventually have people thinking on more of a cradle to grave when you're looking at carbon impacts. Because right now we are pretty much just talking about cradle to gate, which obviously doesn't look as good for concrete because that's where our impact is. But what we are doing is a few things to basically, most of that impact comes from the use of traditional Portland cements, the vast majority of it. Some of it comes from the creation of aggregate and transportation and all that kind of stuff, but it really cements Portland cement. Traditional Portland cement is what the issue is. So a number of things are happening on that front, one of which is that we can use supplementary cementitious materials, which, along with being fun to say, is also very helpful in reducing the amount of cement you have to use. So, for example, fly ash is a very common supplementary cementitious material. So this is a industrial waste product from coal. So it's redirecting this waste into a concrete mix, and you can use it for a percentage of replacement for cements. It can't be 100%. And in the case of precast, we have to think about things like cure time and aesthetics and, how much of it you can use. So there's a way to reduce carbon by doing that. First of all, there's other materials out there too. And here's where some of the really, there's some cool innovation going on, I think. And some of it is very like lab experiment level at this point. But right here in Colorado, we have the National Renewable Energy Laboratory, NREL, and they're doing a bunch of collaborative efforts with, like, I know they're doing a program, I think, with School of Mines to use mine tailings as a replacement for cement, which is another like terrible waste product that we can maybe redirect someplace useful. They're doing a program with using lignin, like a biomass product, in some replacement of cement, and that's supposed to like make a pretty dramatic carbon decrease. And the one that really is, out there and fascinating to me is the Colorado University is doing something with NREL where they're studying like a particular kind of algae to make like biogenic cement. So they're actually growing limestone essentially the way that coral grows, and that they're working to use as cement. So it's a carbon neutral approach. But then there's also things like using crushed glass, pozzolans, and things like that in replacement of cement. So the question becomes, how much of this can replace traditional cement? There's folks who are saying, I was just actually at an event at NREL recently, and had some folks who had some really cool technologies with using basalt instead of limestone, or doing these other types of things to basically get that binding quality of cement without all the carbon. So the question now is kind of becomes which one of these becomes most prominent. But what I'll note is, while all of that is going on, and certainly there are producers who are utilizing some of that, we're seeing a little bit more of it in ready mix and in precast right now, because it usually kind of starts there and then moves on. But something that's happening full front all around the country right now is this switch from traditional Portland cement to what's called Portland limestone cement, PLC, or type 2 cement. It's basically like a 1-to-1 replacement. So, engineers are still kind of fiddling with mixed designs to make sure it does what it's supposed to do, because at the end of the day, we want to reduce carbon, but we also need buildings to, stand up, and we want to make sure that the performance is there. But PLC, I think, saves maybe around 10% of the carbon impact of traditional cement. And then there's also LC3, which is limestone calcinated cement. That's kind of more in the offing right now. Some folks are using it. It's a little more complex, but that would, if we get to a point where we can be using that, that's more of like a 30% reduction in CO2.
And this is where I struggle, right? On the one hand, as an individual, I love the idea of all these innovations in concrete, ways to continue to use concrete, but without having quite the carbon footprint. But as a lawyer and a litigator, I'm also like, okay, what does happen? There's already challenges all the time. People freak out if they see cracks in the concrete. Of course, concrete cracks. I've seen lots of cases where there's actually like installation or design issues, but still they want to blame the product. They say there's something wrong with the concrete. Right now we do have great ASTM standards, for example, I use a lot to defend concrete. There's other standards too. And I guess a lot of those could apply even to some of these newer concretes, but always there is that risk, that defensibility, like you said, if we try an innovative new approach, and yeah, there's structural issues with the building as a result. That is the risky part. And that's where just personally, I struggle. I tend to be more risk averse, but I love that we're out here trying these things. I do love all the ideas of these bioconcretes. And I know, there's even things that are just admixtures that are being added too, right? That can help reduce somehow I don't know if it just increases the strength or reduces the carbon footprint.
Yeah, I know there's some like out there now and others that are being researched and developed, but yeah, essentially admixtures that reabsorb CO2 back into itself. There's also this idea of carbon capture. There's firms that basically take industrial CO2 and inject it into the concrete, so it sort of entombs it there, which, hey, look, we'll take everything we can get. I think that's, that type of thing is more, it's cool, and it definitely does create a reduction, and it helps for a lot of projects that might be having to hit certain levels of EPDs or something like that. So there are those types of possibilities out there. I think, like you, I also believe that something has to work before it really can. We of course want to see the reductions, and it's super important that we do that, but it's also very important to make sure that we do it in a manner that is logical and safe. And I'll say this, like, one of the things in our industry for sure, and I think the larger concrete industry as well, but certainly within the precast industry, all of our plants are like hardcore certified. They have to live by very tight quality control measures, which, it does make it difficult to just go hog wild and just start throwing a lot of the stuff in there. You really have to test it and really have to make sure that it's going to do the job, which I think is important too. So it's finding ways to improve around the edges, I think, while also just making our buildings a lot more efficient. One of the things I say all the time when I'm talking with architects and engineers is material is a piece of it. What really makes a sustainable building is its design, like what it does, what you use the materials for, whether you're using concrete or steel or wood or glass or whatever it is. How is that used to achieve the energy efficiency goals, the resilience goals, because all these things go together. And it's really, I think, everything has a cost, everything has a carbon cost. And what are you getting for it is the question. Because if you're getting good long-term performance, and the reason we talk about resilience, and, part of the reason why I think, we need to be talking more in our industry about the idea of adaptation, is the fact that you can build the most carbon neutral building out there with all the materials that don't have any impact. And if it falls down or burns up in 6 years, didn't really do you much good if you have to turn around and build the whole thing again. So I think that's important to think in the holistic long term.
All right. So kind of tying still on the sustainability side, but segueing closer to resilience, is this idea of cradle to gate versus cradle to grave, or cradle to cradle even, right? If we start looking at more of a circular economy, too often, and this, for example, makes me kind of cringe every time I watch one of my HGTV renovation shows, is you see a perfectly good building starting to fall apart, but then they just basically trash all of it and start over. And to your point, if you have low embodied carbon, but that building's only lasting 7 years, is that really a good building? So, because you have to look at the waste issues, the carbon that's emitted, tearing it down, all of that. So why, I see a little bit of discussion in this in the concrete industry, but I feel like there should be more about the benefits of concrete if you're looking at carbon over the cradle to cradle or cradle to grave, right? Like you said, the lifespan should be longer.
Yeah. And that is, I mean, this is a big challenge for us right now. And honestly, it's something that sticks with me constantly is, and I'm forgetting the exact statistic now, but like I think it was from EPA in 2018, determined the amount of construction waste that was generated. And it was more than all of the municipal solid waste in the country. I mean, it's stunning. So the amount of material and waste that our industry generates, and understanding the fact that I think estimates are we're going to be building like the equivalent of a new New York City like every month for the next several decades. So to me, it's actually a very important part of the conversation to think in terms of we need to stop this idea of building a building with the idea that it's going to last for 15, 20 years and be torn down and be something else, because it's just not sustainable or feasible anymore. Like, we have to be thinking more about long-term performance. And yeah, this is where something like concrete, precast concrete, we can have 100+ year service life, perform at a high level for a very long time. That's all important. The trouble is that when we're talking about initial, carbon impacts right now and talking about embodied carbon, most of the data we have is cradle to gate. So we're just talking about the sourcing, the manufacturing, and everything used to make that material right up to the point it ships out. So that's it. And again, for us, that's where all of our impact is. So we concrete doesn't look as good as, wood in that respect. But when you take it and stretch it out over, there's plenty of studies that show this. If you work in the operational phase of it, which is where about 90% of the impact of a building comes from, and look at it from a cradle to gate perspective, then things start to look a little bit different and you make different kinds of choices. Now, I think part of the struggle is that it's just the projection data just isn't there. And this is actually one of those areas where this kind of came up at the NREL event I was at. I think there's a potential here for AI to actually serve a purpose in helping us really model and show what the real cradle to grave impact would be for something, like to really do run like a digital twin and see what a building does over the course of 50, 60, 70 years and have a better picture of what that looks like. So I think that's where we need to go to really be making better choices in general about how we build buildings. But also, I think what's inherent in that, and when we're talking about adaptation and resilience, I mean, precast is a great material for hazard resistance. So we use it, and it's FEMA storm shelters are very often built from precast. We've done wind cannon tests that show precast wall panels standing up to like 100-mile-an-hour projectiles being hurled at it, and it's used in hurricane zones because it's good against scour and all those kinds of things, and fire also. Like, we've seen precast or concrete buildings survive wildfires and things like that. So right down here in Colorado, it's a big piece of conversation. I mean, I live not far at all from where the Marshall Fire took place. And it's a big consideration of how do we build in a way that we mitigate those kinds of threats. So that has to be more of the factor. I think we really need to see sustainability and resilience being the same conversation in a lot of ways, and look at it either to a cradle to grave or cradle to cradle. I love the concept, cradle to cradle. I was a fan of William McDonough's book that laid that out. Nature has no waste, so nor should we. And so I think there's potential. Like, we're even seeing now there's work being done with concrete to crush it up and use it as aggregate in new concrete to higher percentages. So more of that kind of thing is what I think we are strive for. But also, when you talk about long-lasting buildings, I think it's important to talk about adaptability, because the simple fact is you can talk to an architect and say, like, well, yeah, we want to build this to last 100 years. And they may say, well, okay, do you think it's really going to be doing the same thing in 50 years or 30 years or 20 years that it's going to be doing now? And so we have to think about ways to kind of future-proof these buildings and make them able to change and be used for different kinds of things if we're really serious about having a longer lasting building stock.
Yeah, you're talking about adaptability of the use, right, of the building.
Yes,
But
correct.
I also want to, and also, we'll talk about climate adaptation or climate adaptability as well. But I want to hone in on something really interesting. I agree that we don't quantify the carbon in the lifetime of a building when it comes to avoided carbon from repairs or reconstruction because of severe weather events, right? So here's an ask to all of our audience and our network. If you know of folks doing LCAs, life cycle analysis, that include carbon avoided because the building had the ability to withstand a severe weather event, And we didn't have to repair, we didn't have to rebuild, etc. I'm yet to hear of LCAs including that. So reach out to
Very
us
good point.
yes.
Yeah.
So let's hone in on that topic of climate adaptation and resilience side of concrete. What are the strengths and the weaknesses of concrete, precast concrete in particular, when we're talking about the resilience to the effects of climate change and severe weather events in general?
I mean, I think it's, basically it's just inherent durability makes it a very attractive choice for something when you're talking about thinking about worrying about future weather events or even seismic. We do a lot of seismic design with precast out west. I mean, that's an important aspect too, because, the trick with seismic is having the building essentially be strong and flexible at the same time. And, something with the way that we use connections and the pre-stressing strand and all that really helps in that type of design. And where it comes to storm resistance, I think it's a very strong, durable material and can stand up very well against tornado force winds and hurricanes and those kinds of things. So just on a very simple, I always kind of think of durability as the ability of something to take a punch. And when we're talking about resilience, that's taking it a step further and saying, can it continue to do its job after that punch? And I think that is what concrete in general is pretty good at. It stands up really well against those types of forces, and then it's able to continue doing its job. I mean, the example we often use, and I think is a really compelling one, was if you remember the tornado that hit Joplin, Missouri back in, I think, 2011, pretty much destroyed that town. It was a really tragic storm. One of the few buildings that survived was a precast shopco, big box, right? Hadn't been used in several years. It was abandoned. The storm happened in May. They were able to actually retrofit that into the new Joplin High School in 55 days. And so the kids were actually able to go back to school on time in the fall. And to me, that's the definition of adaptability and resilience. It's like serving that purpose for that community. They were able to continue even in the midst of that tragedy and all the picking up and rebuilding they had to do. Their kids were able to continue that part of their life because of the strength and durability and adaptability of that structure.
Yeah, always good to connect the buildings to what they're used for and the people that use them, right? And the communities that need them and depend on them.
Yes, I think we probably don't talk about that enough. A building is not just a thing that's out there. It's a living, breathing part of a community.
Well, and that's actually, it seems to be a theme that's developing for this season of this functional recovery, right? Like you said, not just being able to withstand extreme weather event or something, but be able to come back, to be able to continue to contribute to the community. We tend to focus on, in the built environment, or at least I do often as a litigator, each individual project, right? But yeah, none of them are an island. They are all part of our communities, our businesses, our lives. So that ability to withstand or recover quickly from the extreme weather event and the climate change is such an important part of any discussion about adapting to changing climate. So in that vein, one thing that I've had people ask me, lawyers and other people in various kind of the construction trades and everything, is just for resources, right? There may be this general idea that, yes, we should do something, but people are like, I don't know how. And so much construction in some ways is sort of like the law, where we tend to look backwards a lot. This is how we've always done things, so this is how we're going to continue to do them. So are there resources or guides or even codes out there that can help architects and engineers and others figure out how to use concrete to basically incorporate resilience to climate change?
Yeah, I think within our industry, there are several, I think, great, like sort of just online resources with lots of documentation and webinars and courses and things. I'll say that National Ready Mix Concrete Association, NRMCA, has done some great work in this area. They have a website called Build with Strength, and it talks a lot about, broad concrete. I mean, that's the thing, like precast is one type of concrete. There's others too. And we share certain types of attributes and other things are a little different, but there are some really good conversations and resources on that site to talk about some of the things that are being done with resilience, or some of the ways to think about resilience and design and sustainability. PCI has a great sub page on their website just focused on sustainability and resilience, and we've been working on a program there called Precast Protects Life, And by life, we mean not just physical life, but also livelihoods, lifestyle, their day-to-day life. Like, so it is this idea of building with the idea of resilience in mind, where communities can continue to do their job and stand up to fires or storms or earthquakes or whatever it might be. So there's, some case studies and webinars and resources available there at precastprotectslife.org. Like, in terms, I will admit, like, I'm not as sure, like, I don't know as much about the code zone or like the standards. I know there's things out there that are probably linked to from those, but we have like, model specs and all kinds of things on those websites. And I know PCA is another organization that's worth checking out. The Portland Cement Association, they have a like road to carbon neutrality outline program, and they've been working really hard within the industry to kind of work towards these lesser impact types of cement and move the industry in that direction. So they've got a lot of good resources. I think there are some different resources out there for like availability of Portland limestone cement too. So yeah, lots of things like that for folks who are interested in seeing how they can deliver a more carbon friendly project with using concrete.
Water has always been a challenge, but it's becoming bigger, right? Either it's sea level rise or flooding or extreme rain. What are the challenges with concrete and water?
Yeah. So, I mean, a couple things. First of all, concrete uses water. So, when we produce it, that is something we have to think about too. And what I'll say, that's an area where something like precast, especially because of its material efficiency, gives us some opportunities to really save and maximize the water that we do use. I know there are some producers we have around. I know there's a couple in particular I'm thinking of in the Southwest who have these amazing water reclamation systems in their plants where they just retain and reuse just about every drop of water that they have, and they take that very seriously because that's a really important resource to conserve. I don't care what industry you're in or what you are right now. But also in terms of the durability and kind of the storm design of the material itself, part of the reason it is used on quite a few FEMA rated storm shelters and safe rooms and things is because not only is it strong against windborne debris, it also can be durable against scour and kind of air you get around the sea, seashore and things, the salty atmosphere. So it can be designed to be resilient to those types of forces as well. And a great example of that, I think, is this Statue of Liberty Museum, which utilized precast. So this was built in the aftermath of Hurricane Sandy. So they were really thinking in terms of like, well, we are going to be experiencing increasing storms and flooding in this part of the country now. Like, it's kind of just the new reality. So it was built with that in mind, and actually built like above 500-year floodplain, and then also does have these cutouts underneath that is designed to actually take in floodwater and store it and evacuate it so that it doesn't impact the foundation of the building. So it actually is accounting for that. And then use precast for energy efficiency, because on top of being a very resilient project, it was also LEED. I can't remember if it was gold or platinum, but it had high sustainability goals as well. It has like a green roof. It used precast. It used those insulated precast wall panels I was talking about earlier to achieve a high level of energy efficiency and performance. So that's an example of a project where they wanted it to be durable, long lasting, and also just recognize that it's going to have to stand up against tougher conditions in the future.
I've had this question for a while. Maybe you know the answer to this. Concrete uses a lot of water in its production. And you talked about water reclamation. Does that water that is used for concrete production have to be potable?
I believe per ASTM standards, it does, I think.
I guess you reclaim the water, you treat it, and then you use that water already treated.
Correct.
Okay.
Yes. I would have to refer to some resources on that one, because I have to say I'm not an engineer, but I'm relatively sure it has to be potable, but I would have to verify that.
I know in construction, we're looking for ways to reuse water, right? We use most of the industry uses water as like, it's not a limited resource, and it is a limited resource. So that question, I've had that question in my mind for a while, but we won't quote you on it.
Yeah, that's right. I'll circle back to you on that one, but yes, I think it has to be potable.
Excellent.
But yes, I know there are some pretty sophisticated water reclamation systems in a lot of our newer plants right now. It's something that the industry is definitely taking seriously.
Another issue, I'm obsessed with water generally, and yes, the lack of water or overuse of water in many areas. The other issue, of course, that I'm always obsessed with is heat. I hate the heat. Monica and I had a whole episode last season on heat, focusing on its impact on people, right? So we talk
Mhm.
a lot about like the impact of extreme heat on construction workers during the building of a project. But what about, we've talked a little bit about some materials. Is there any interaction or any issues in the concrete world dealing with extreme heat?
I think it can, and I was talking to an engineer about this, and I think, to be honest, so I one of my members has a plant in Phoenix, and as you know, they have some heat issues there from time to time.
This
Uh,
year in particular, what? I think
right.
there are over 100 days now of 100-degree heat or more, which I can't even imagine.
Yeah, I used to, in my previous life, I would travel to Phoenix in the summertime sometimes, and it is unbelievable. Honestly, though, I think there is an impact on, the curing of concrete when it gets to some of those extreme temperatures. It's sort of one of these things where I think the bigger impact is the human one, frankly. Like what they have to really contend with is the fact that they're running shifts in the afternoon and evening and not during, or morning and evening and not during the afternoon, because it's just not possible. Like, so it very well could be that those extreme temperatures would also be bad for the concrete, but because there's no human that can even be out there doing it at that point in time, that actually ends up being the kind of the break point there. So we have to be thinking about those kinds of things. I will say that temperature does impact, I think, curing time or some of the qualities of concrete. Because one of the things I know, I've heard producers talk about is in cooler temperatures, like so here in Colorado, like in the wintertime, it becomes a little less, we can't use as much fly ash as you can when it's warmer out. Like there's some mixed, kind of considerations that come out of that. So yes, it can be a limiting factor though, when you get to these extreme temperatures, as it is in construction in general. People really become the limiting factor even more than the materials do.
Are there any other challenges that people may not think about when it comes to concrete and resilience? And I'll give you an example.
Mm-hmm.
The other day, my 10-year-old daughter asked me, Mommy, where do roads sit on? Like, what does like pavement and concrete sit on? And I'm like, well, just land, like dirt. So thinking of like
Right.
land stability, right?
Yeah.
Are there challenges regarding concrete and resilience?
Yeah, there certainly can be, depending on where you are and what because I mean, obviously concrete is heavy and there are limitations to what you can do. So you do have situations, depending where you're building, where you may have to have piles or drive down to, lower depths for that stability. And the other, limitation, when we're talking about precast specifically, there are kind of practical height limitations when we're talking about what we call in the industry a total precast structure, which means, because with precast, we could be talking about structural, like we have buildings that may have structural precast, and then architectural might be glass or steel or something else. But some buildings, and we have quite a few here in Colorado, have structural precast and then also architectural precast. Those are typically limited to maybe 12 stories or so, simply because of the weight of the material. It just gets to be difficult to go above that. Although we also have buildings that use just architectural precast. So you can have a different type of frame, might be steel or cast in place, and you can go higher with that if it's just cladding. There's a Hyatt in Chicago that's got precast cladding that's, I don't know, 50 stories or something like that. And the Transamerica Pyramid, I should note, has precast concrete cladding on it. A point, by the way, that I raised when my kids were watching the Sonic the Hedgehog movie, because the final battle takes place on top of the Transamerica Pyramid. And I was like, kids, did you know that this is made from precast concrete? And they didn't find that terribly moving, but I tried.
We would have found it very interesting.
Yes. I think that would have been the only thing interesting about that movie, which
Right. So
I
yeah.
say every day, I'm glad my kids were too old for those movies. So
at least caught my interest in the final battle. That's good. Oh, there we go. Yeah.
All right. Well, one other kind of odd sort of tangent, but coming back to what you talked about early on with the fact that precast concrete is used a lot in parking garages or parking ramps, as they say here in Wisconsin, which I just find adorable.
Oh, me too. And I'm going to go get a drink from the bubbler.
That's right. But one thing that I've actually heard folks that I work with in the precast concrete industry talk about is this whole issue kind of is a tension right now between the rising popularity of EVs, electric vehicles, and especially charging stations that you need for these EVs, which are often put in parking garages, right? But all of a sudden you've got EVs. My understanding is in general tend to be heavier than regular, I'm not a car person, but
Right.
gas cars, I'll call them,
Yeah.
that they're heavier. And then of course with the charging stations, you tend to have all the EVs then in like one particular part of the parking garage. Obviously, if you're designing a new parking garage, they would take that into account. But I mean, is that a concern? Has there been discussion about like if we're retrofitting parking garages and putting in EV charging stations, are we talking about that weight, or are there other issues to be thinking about with the EVs?
Absolutely. We are talking about that. In fact, yeah, we have like task groups within PCI who are having this exact conversation. I know there's research being done because it is. And in fact, I'm actually going to circle back to the question Mónika asked about resilience. Some of the things that we may see as being, potential not as strong as we'd like it to be. I will say this: precast or concrete in general is excellent with fire. Like, it's very fire resistant. However, the extended heat and long burn, I mean, on the rare occasion that an electric car does go light up, I mean, it'll burn for like 15 hours or something like that at super intense temperatures, and that can be a problem. So that is something we have to consider when we're designing for that type of vehicle now. And that comes down to little things like considering what the space is like. Are the spaces a little bit wider to make sure that if one does catch on fire, it doesn't catch the next one right next to it? Suppression systems, all those kinds of things do become a conversation when we're talking about EVs. And weight absolutely is another piece of it that we have to be thinking about. How do we distribute this? And maybe it's tweaks in design. Maybe it's talking about having, okay, we have one EV section here and another EV section there to distribute the weight more evenly. So it certainly does create considerations for us. It's not, and it's turning into a challenge in certain places, like, and I'll say Denver being one of them, because we have new state law and city code that's really trying to decarbonize and electrify, which is great. But some of it does presuppose that, like, oh, it's a one-to-one switch that we can just have all these electric cars on this existing parking structure, and it's a little more complicated than that. It's not to say it can't be done, but it does require design and forethought. We have to be considering that.
Yeah, and there can be unintended consequences if we don't go through the whole analysis. Yes. So that's a really good point. I do have a couple of translations for the audience. So you mentioned it, Jessica, parking ramps are parking garages and bubblers are drinking fountains. I did not know that. So I had to Google that.
Yeah, these are little Wisconsinisms. We have quite a few of them.
Yes.
I love that. I love learning new things about different places. Are there any other things you want our audience, and our audience just, it's real estate developers and real estate investors and construction folks, designers, architects, litigators, and resilient consultants, and folks in sustainability as well, I know, listen to our podcast. Is there anything else you want them to know about precast concrete and climate change?
Yeah, I think it can be very easy to and I think there's been a little too much sort of silver bulleting certain materials or products or whatever in the last, because I've been around. I used to write for a Green Building magazine. I've been kind of in and around sustainability for 20 years. And you see different trends and different things kind of get hot or different kinds of messaging around different things. And I know, look, concrete to the, still when I talk to, students about it or go out and talk to certain architecture firms, it just kind of gets this initial like, oh, well, carbon. It's like, sure. Yeah, we have a carbon impact. I don't deny that. But also I think it's important to think about what you get for that, and maybe I think we need to stop thinking of materials as a single faced thing, because I think precast has its place. Cast in place concrete has its place. Steel has its place. Wood has its place. Like, all of these things can really be a contributor to a truly sustainable design. And that's what I think is the important thing, is thinking about it from a holistic standpoint, and how can this particular material help me? And I think concrete can really help in certain areas. It can help with energy efficiency through thermal mass. It can help with durability and resilience and having a long lasting structure. It can help with healthy building concepts because it's inert. It doesn't have VOCs. It is durable and safe and fire resistant and Acoustic has a lot of acoustic qualities that are important for healthy buildings. So it's understanding what the attributes are of a material and then thinking like, okay, what's the right mix of trade-offs here? Like what, how can I then pursue using concrete as a material in this application and make sure it is as durable, long-lasting, and resilient as it can be, can stand up to the changing world of tomorrow, which I think is an increasingly important thing. We have to walk and chew gum at the same time. We had this discussion when we were back at the National Institute of Building Sciences conference, where you can't have this standoff between mitigation and resilience. They really are the same conversation. And I would say to think about concrete as something that really straddles that. There are considerations where it comes to its carbon impact. There are ways to mitigate that, but it's also important to think about what are you getting for it? What's the performance over time? What's its long-term impact and its long-term benefit?
I think those are all excellent points. And this has been a great conversation. I am biased, obviously, because I do love concrete. So,
Me
Jim,
too.
So I very much appreciate you talking to us today about that. Before we let you go, we do have to kind of switch gears and talk a little bit about you. You're actually starting your own podcast. Mónika and I are going to be on it.
Yes.
So we want to give you a chance to tell our audience about what your podcast is going to be about.
Well, I appreciate that very much, because I will say that while I'm sure my podcast will address concrete in some way at times, it's actually not what it's about, but I'm really excited about it. It's called A Pessimist's Guide to Optimism. And what I'm trying to do is talk to folks like you guys, because what I've discovered, and yes, I'm a bit of a pessimist. I'm a Gen Xer. We're always a little disaffected and like, all right, when's the next shoe going to drop? But I really want to be an optimist. And that's kind of the idea behind this. So what I've found over the years in writing, talking to architects and thinkers and people in the sustainability movement, I get so inspired by some of the things that folks are actually doing out there to really make a positive difference in all kinds of areas in life, and not just construction. So I'm kind of having this podcast, the idea of talking to a lot of folks who are thinkers in different areas. I've done a few interviews already with somebody talking about parenting and education issues, and somebody talking about religion and society, and talking about all kinds of other AI and the future of design. So I'm trying to talk to these folks to find good reasons to feel optimistic about the future. And that's why I'm going to have you guys on, because listening to your show makes me feel optimistic too.
Well, thank you. As a fellow pessimist, I'm going to be listening to your podcast because I would also like to feel optimistic. But I'm also happy to hear that we make you feel a little bit optimistic. Right, Mónika?
Yes, it's an honor. I would have never guessed that you're both pessimists, by the way. So I'm sometimes annoyingly optimist. So that's a whole other thing that we can maybe talk about in your podcast.
I love that. And I think that's good. For heaven's sakes, we need that. And we need all perspectives, but that's got to move in that direction, because apathy is the enemy. I think that's kind of my guiding light. I have little kids and I want a happier, more sustainable future for them too. So I have to be optimistic, and I will find my way there.
The future generation certainly gives me hope. Yes.
Yes, me too.
All right. Well, I think that is a great and cheery note to end on. So thank you, Jim, so much. I look forward to being on your podcast and listening to your podcast. And I'm really excited for everybody to hear our conversation about concrete.
Yes. Thank you, Jim.
Thank you, folks. It's an honor to be here.
Thanks for listening to Adapt: Climate Change and the Built Environment. We hope you enjoyed this episode and come back to hear more of our conversations with people leading the way and addressing the issues facing the built environment as our climate changes. Please rate, review, and subscribe, and share our podcast with others who may be interested. And if you have any feedback or suggestions for topics or guests for future seasons, we'd love to hear from you. You can email us at adaptthebuiltenvironment@gmail.com. Thanks for listening.